So we need to understand the distribution pattern of the data. This is also very much important. There are 4 different types of distributions. One is symmetrical distribution, skewed distribution, the other one is uniform distribution, and the last one is kurtosis. Okay. We already discussed about the normal distribution, right? We already discussed about the normal distribution. The normal distribution is also called as a symmetrical distribution. So now the question is, right, when it comes to skewed distribution, so why do we need to find out the skewness? So the skewness is helpful to measure the level of asymmetry in your distribution. It is the measure of asymmetry. Okay, symmetrical is distribution. It's a measure of symmetrical. Okay, uniform distribution, kurtosis, we'll take a look at it. So look at here. This is called your symmetrical distribution. Okay, this is called your symmetrical distribution. What is symmetrical distribution? It is a type of distribution where the left side of, in this case, the left side of the distribution mirror the right side. If I draw a line exactly in the middle, that is what your median. You just assume that is a straight line. Okay, so in this case, the symmetrical distribution, the left side of the distribution mirrors the right side of mirrors the right side. Okay, and also in symmetrical distribution, in this case, the second thing what you need to remember is the mean is equivalent to median is equal to mode. It is always true. Okay, when it comes to symmetrical, mean is equivalent to median is equal to mode. You need to remember these things. First one is the left side of the distribution mirrors the right side of the distribution. Okay, if you draw a line exactly in the middle, that the 50% of this area, right, is a mirror image of the 50% of data on the right side. This is called your symmetrical distribution, or it is also called as a normal distribution. It is also called as a bell curve. It appears like a bell. Okay, so people use interchangeably these 3 terms. In general, they use the bell curve or normal distribution. Okay, now let us see with some practical example. So normal distribution. So is this a normally distributed data or skewed distributed data? We have a variable called salary. I have a variable called salary. Salary is a quantitative variable. Okay, salary is a quantity. So I have plotted. This is called your histogram. Please remember this. This is called your histogram. Using histogram or box plot, you can find out the distribution pattern. What do you mean by distribution pattern? Whether the data is normally distributed or skewed or uniform distribution or kurtosis, right? You can find out with the help of these charts, histogram or box plot. Histogram and box plot is meant for statistician and data scientist. Only they can understand this one. Unlike other charts, these 2 charts can only be understood by statistician and data scientist. So look here. Now the question is, what is the difference between histogram and bar plot? See, bar plot is also something similar, right? Here's something like bar plot. Okay, if you want to compare more than one category side by side, this bar chart, column chart, we call it column chart. These are very much helpful. But the distance between the bar chart and there are no gap between these bars. This is what called as in the case of bar plot, you have a gap between the columns, these bars. In the case of histogram, there is no gap between these bars. That is what your histogram. So using histogram or box plot, we can find out the type of the distribution. Let's say I have plotted salary in x-axis. In histogram, you know you can plot only the quantitative variable. Okay, that too you can plot it in x-axis only. So what the hell y-axis is all about? This is my y-axis. What is y-axis? This is for the histogram. Okay, it automatically counts the values. It displays the y-axis displays the count. For example, the salary, right? So let's say 1,14,000 to 1,15,000. How many number of people? Let's say here instead of 1 you have 100. Okay, it's all in hundreds, 200, 300, 400, 500, something like that. Okay, the units are in hundreds. You just think that way. So 1,14,000 to 1,15,000 in my company, 100 employees are getting this salary. 100 employees' salaries are falling between this range, and similarly 115 to 116. So even 100 employees, between these two range. So 100 employees, their salaries are falling between this range, and again, right? So other 100 employees are likewise. You need to interpret. So if you see here, this one, right? So 1,17,000 to 1,18,000, 200 employees are drawing the salary. So now if you see here, if you join this corner, it will be something like the bell curve. It will be something like a bell curve, right? Bell curve. It's a normally distributed. So on both the sides, the tails are going smoothly like this. Okay, the curve, we can see a curve, and on the both side you can see these lines are going this way. The middle one is your median. Okay, in the case of normal distribution, this is a normal distribution. The mean is equivalent to median is equivalent to mode always. Okay, you remember this. Now with this, okay, now I plotted salary in an histogram. And mentally I just draw the line. With this I can make out is a bell curve, normally distributed data. Fine. What is so big deal? So what am I going to infer from this? Okay, supposing in your company, right, your CEO, of late is getting complaint. He is saying that right. So there is a bias in this salary. Salary is not given in a unbiased manner. There is some kind of bias. So he has a concern. He calls his people. It's not a skewed data. It's not a skewed data. Okay. It's not a skewed data. Okay. I'll explain you the skewed distribution little later. It is a non-skewed data. Okay. Okay. Here, it's maybe right. Symmetrical distribution. Symmetrical distribution. Right, so or normal distribution. So I plotted my salary. So as a CEO I'm concerned. So we want to be very objective when it comes to salary. There is no bias here. Okay, gender bias or sex bias. Okay, there should not be any. Sorry, both of them same, right? Yeah, there should not be any bias. Okay, so you call the data scientist and ask them to investigate it. Are we biased? Your data scientist, plotted salary in the x-axis in the histogram. The histogram was automatically created like this. With this, he says, as soon as he see this pattern, bell curve, he says, we are not biased. As let's say you are a CEO, you are not clear, and you are asking him, hey, can you please explain this in detail? You are a statistician or you are a data scientist. You are saying it is normally distributed. Just because it's normally distributed, we are not biased. Can you please explain in detail? So look here. You take any software company, okay, but I don't know about other company. Okay, software company. Only few employees are getting less salary, and only few employees are getting very high salary. Rest of the employees, right, based on their rank, they are getting their salary. Only few employees are getting less salary in software company. Just because somebody says I work in software company, that doesn't mean you should get more salary, right? In the software company also there are some clerical jobs, clerical guys, accountant, These guys and support function guys, right? Support function, support function guys. These are called support function. Clerical, accountant, they are paid less. Whereas if you see the developers, like a Power BI developer, Java developer, they are paid very high. Non-developers, non-IT people are paid less. On the other hand, if you see here, on the other end, if you see it here, in this tail, if you see here, only few of the people are getting lesser salary. Only few of the people are getting higher salary. See here, 1,27,000 to 1,28,000, right? So how many people are getting this much salary? 200 employees. Okay, and if you look at this one, 1,28,000 to or 1,29,000 to this one, the last one, 1,29,000 to 1,30,000. Only 100 employees are getting high salary. Only few employees are getting high salary. Only few employees are getting less salary. So why only few employees getting very high salary? Because they are chief finance officer, chief executive officer, chief operating officer, directors. In a company, how many CEOs will be there? Hardly one guy, right? And chief operating officer maybe one, chief financial officer maybe two, or that's all. Hardly few guys are there in the top of the hierarchy. Only few people are there in the top of the hierarchy. Hence, only few people are drawing higher salary. Only few people are at the bottom of the hierarchy, right? These people are just doing clerical job. Their salary is less. But if you look at something, for example, if you take a look at this, right? So let's 122, 121. If you take a look at this, I'm talking about this one. Okay. So if you see 1,22,000, 1,21,000, 500 employees are getting. So maybe they are Java developers or data scientists, right? So their salary are something 1,21,000 to 1,23,000. So how many people? 800 people are getting this much of salary, right? So 1,21,000, 1,23,000, something like that. Okay. So only few people are getting less salary. Only few people are getting very high salary. Rest of them, they are getting salary based on their skill set or based on their level. Hence, we are not biased because the distribution is normal. Similarly, if you use a box plot, look here, the median is appearing exactly in the middle. So the distance, after this one to this one and this one is more or less same, right? Hence, it is symmetrical, normal distribution. In the case of box plot, it's a bell curve. In the case of this one, the box, right, and the middle box, exactly in the middle of the box, you will find the median. Both the distance, the left side distance, the right side distance will be more or less same. Either you can use, in practice we use histogram only to find out whether the given data is normal distribution or skewed data. So next one is one second, let me just clear up all these things. This is normally distributed. So now this is called your right skewed data. Right skewed data. So what do you mean by right skewed data? You see here, when you plot the given data, you are not getting something like this, bell curve. Right? You are not seeing bell curve here. Instead, only on the right side you are seeing it, right? You are not seeing the left side. So here you can see a peak here, and then if I draw a line here, it comes like this, right? The tail is flattening completely on the right side. This is called right skewed data. It is also called as positively skewed data. They use interchangeably. They use these two terms. Once you get into a project, you are not supposed to get confused when the customer either use this term or this term. That's why I'm using all the terms, positively skewed data or right skewed data. So here is something like this. So in the case of positively skewed data or right skewed data, what will happen is the highest one is your mode here. This point is mode here, and your median will be somewhere falling here, and your mean value will get dragged toward the right side, the mean value. In the case of right skewed data, the mean will get dragged at the the right side. Whereas in the case of normal distribution, the mean, median, mode all falls in the same place. In the case of right skewed data, so the mode the falls here, and because the most frequently occurring values between 60 to 56, 60 people are there, something like that. Okay, so majority of the customers' age is between these two things. You just think so, right? So that is what your mode. This is not male, this is mode. Okay, so now you tell me what is the answer, which one holds true. Obviously mean is less than median and median is less than mode. Okay, this one seems to be the correct match, but if you see in the middle one, you just look at the middle one median is there, right? How many of them we have median? So here and here, in both the cases we have median here, but here the mode is less than median. So does this mode is less than median? No, right? Mode is bigger than, so hence the answer is this one. So mean is less than median, median is less than mode. Or we can say like this, mode is greater than median, median is greater than mean. Ideally it should be like this, greater than, okay. Since it is less than, it is wrong here. So we have only two choices. Of these two, this is the correct one, this is not the correct one. So this is what your right skewed data. Look at here, I just put this one. This is your positive skew because the tail is flattening like anything on the right side. In this case, the tail is flattening like anything on the left side. So this is, since the tail is flattening on the right side, abruptly, something like abruptly, right? This is called your positive skew. If the tail is flattening abruptly on the left side, negative skew. In both the cases, if you notice one thing, the tallest one, right? This is what the peak is your mode. Here also the peak is mode, and the mean get dragged outward. Here also the mean got dragged outward, but in this case, since it's negative skew, the mean got dragged outward towards the left side, whereas it is right side. Very simple, right? Remember this. What is positive skew? So mode is greater than median, median is greater than mean. So in this case also the same thing, mode is greater than median and median is greater than mean. But only thing is the tail, the difference is tail here. So next one is, where does the mode occur on this distribution? See, when I plot the data, I get a straight line. So what does it says here? Where is the mode? What is mode here? The mode is the peak, right? The peak is the mode here. This is the peak. After this, it is gradually falling down, going down. But now you tell me, where is the peak here? Peak is the mode. Where is the peak here? Can you tell me, does this distribution has mode in it or not? Palani, where does the mode occur on this distribution? There is no mode here. In this data set, we don't have mode because we don't see any peak here, right? So what kind of scenario we can, supposing you are running a catering service. You are running a catering service. So what you do is every month you deliver food to 100 customers only. Okay, every month 100 customers only you deliver the food. So each month whatever the revenue you get, the same thing till the year end you will get it. But if you see here consistently, all the month in a year you served the food only to 100 customers. Hence your revenue also something uniform. This is called your uniform distribution. Uniform distribution does not have mode. Remember this, because we don't have any peak here. Yes, Smriti, you are correct. So next one is binomial distribution. So we discussed normal distribution, uniform distribution. We have something negatively skewed and positively skewed data. The next one is binomial distribution. We have, how many modes are there here? Can someone tell me? Let me see how many of you can answer it correctly. How many modes are there here? What is mode? Most frequently occurring value. How many modes are there? We have two modes are there. I gave you a clue. No, Karthik. We have two modes. What is mode? Most frequently occurring value. See here, let's say the shoe size. I'll give you this example. Shoe size of the population, right? Let's say you are running a survey, and then look here, 118, and this is the shoe size. You just think, right? 118 inch to 119. This is the shoe size, and this is the one occurs more time, because look here. Let's say all these values are in terms of hundreds. 700 customers, 700 female shoe sizes, 118 to 119 inch. You just think that way, or centimeter, something like that. Okay. And this is female. We plotted both female and male, and if you see male, the most frequently occurring value is this one. See, if you see the peak of all these things, which one is the peak? This is the peak, right? Here it is. Since we have two peak, we have two mode. That's the reason why we call it a binomial distribution. I plotted the data. My data is both female and male related, male on females shoe size. Okay. The majority of the male here, if you see here, if I draw a line here, sorry, if you draw a line here, what will happen? Almost, right? Almost something like this. 850 male, 850 males shoe size is what? 126 to 127 inches. And here female, right? So the majority of the females shoes size is 118 centimeter to 119. Let's say you are running a shoe factory. You are manufacturing shoe. Now you tell me, in which size of the shoes that you produce more for both male and female. Did you understand my question? Which size of the shoe that you will produce it more for male and female? Are you sleeping, guys? I'll just wrap up this. Don't worry. Okay, I think it is already too late. Henceforth you will not be able to. 7 and 9. What do you mean by 7 and 9? 7 and 9. Superb, right? Yes, Mala. Majority of the female shoe sizes, you will produce this one. Between 118 to 119, this size of the shoes you produce more for female. Between 126 to 127, for this size you produce more. Why? Because this size is used by majority of the males. 850 males in the population, their shoe size is this one. And then 700 females, majority of the females shoe size is this one. You produce more. Let's take this example. So 300 females shoe size are 114 to 115. Will you produce more number of shoes in this size? No, right? If you produce more number of shoes, what will happen? Majority of the female sizes falling between this range. The size is bigger, but if you produce more shoes with this smaller size, no one will buy. Oddly, 300 people, they buy, right? If you produce 1000 shoes, what will happen? Only 300 shoes will be purchased. Remaining 700 shoes will lie idle. So with this, you are able to understand, so how this distribution tells the story. Storytelling is very much important when it comes to data scientist, right? As a data scientist, should be good at storytelling. With this, we are able to tell the story very clearly, or this visual itself tells this. So when you look at this visual, you should be able to tell majority of the female sizes 118 centimeter to 119. Hence, if you produce more number of shoes, or if you produce 700 shoes in this size, it makes sense. or rather if you produce 114 to 115 centimeter size 700, what will happen? It will lie waste, lie idle, we will not be able to sell. Similarly here, see here, just by looking at this visual or chart, we can say it's a binomial distribution. We have plotted both female and male. With this we can find out the mode here, right? So the two modes helps us to understand the most frequently used size by female. Majority of the female or majority of the males most frequently purchased size is 818 to 119, 126 to 127. Hence, see how it helps you to drive your decision, right? It helps you to drive the right decision. Let's say you don't know all these things blindly. If you go by your intuition, and if you produce between 114 to 115 size of shoes of let's say 1000 shoes, what will happen? You are gone. To make the right decision at the right time is very much important. With this kind of analysis, you are going to make the right decision. If you don't blindly, if you produce 1000 shoes in this size, you are gone, right? Most of the time the business fails because they don't do analysis, they don't act on time, they don't take the right decision, they don't have the right tool at the right tool, right? To make the right decision at the right time, you need to have the right tool. Next one is, now you tell me, we can use mode to categorical data also. I gave you the clue. We can use mode on categorical data. Okay, so now you tell me what is the mode here. I told you mode is what is mode? All of you type it in the chat room. Let me see if you are able to follow me or not. This is one way of making sure that you are following me or not. I am trying to help you. If you don't respond, that you are not able to understand. First of all, tell me what is mode. Type it in the chat window, just one liner. What is mode? Come on, yaar. Highest frequency, most Karthik, correct, most frequently occurring value, right? Or the most popular value, most frequently occurring value. That is what your mode, right? Please concentrate here. Most of you are not concentrating here. Most frequently occurring value. Okay, now you tell me what is the mode. Which value is occurring more frequently? Okay, somebody typed. Let me see how it is. Okay, repeated value. Yes, most popular values. Yes, Jiva, correct. What is the mode here? I mentioned categorical data. What is categorical data here? The x-axis male, female, right? So we can see tallest bar for male, which means more number of male customers, more number of orders we received from male population compared to female. So in this case the mode is male. Male is a categorical variable. Sorry, gender is a categorical variable, right? In this case the male category is mode because it occurs more than how many? 35,000 male 35,000. Mala, are you watching here? Male and likewise, right? So 35,000 the male is occurring. The most frequently occurring category is male. That is what it tells us. Got it? We can use mode for categorical variable also. Okay, okay, now you tell me what is the answer for this. All of you, let me see how many of you watched, paid close attention. With this, I'm going to wrap up. Don't worry, okay. So, which one is applicable? Mean, dash, median, dash. First of all, tell me, is this a normally distributed data or not? Yes, it is a normally distributed data because I mentioned here, is a normally distributed. So, in the case of normally distributed data, what is the property here? Mean, dash, median, dash, mode. What is this? Vijay, Vidya, very good. Vidya says main is equal to mode is equal to median. All of them are same. Okay, Mala says equals. All of them are same, right? Mean, median, mode, all these values are equal sign. You need to specify equal sign here. In this case, you need to specify equal sign here. Okay, this is equal sign. Okay, fine. So okay, now you tell me, let's say in this case, see with this I'm going to wrap up. Okay, sure, okay. I'm sure you people are tired. So in the x-axis we plotted income. So between age between 31 to 40, their salary is like this. Okay, 31 to 42, 41 to 50, almost 40 or this is income. Okay, 31,000 to 40,000 and 41,000 to 50,000. Okay, the salary is drawn by 40 people, something like that. So here less than 31,000, right? So this is the population. Probably 3 or 4 people, they are getting less than 31,000. So and right. So now you tell me what kind of story you can tell it out here. What kind of story you can tell here? No, don't say all are equal. Okay, all are equal. Like I said earlier, only few people are getting lesser salary, only few people are getting very high salary, rest of them are getting salary on par with their level. So here most of the employees salary is between 31,000 to 70,000. Look here, the tallest thing, right? Most of the employees 80 employees, 60 employees, and most of the employees salary is between 31,000 to up to 70,000. You just seen up to this one. And next one is only few employees are making more than $71,000. If you see here, so less than 20, right? Less than 20, maybe 10, 5 year, maybe 3, 2, 1, right? So only few people are making more than, say, this is how you need to specify. This is the story you need to tell your management. Only few employees are making more than 71,000, and if you see, it's all flattening. Okay, and here it is up to this, it is tall, right? Majority of the people salary is falling between 31,000 to 70,000. So only few employees are making more than 71,000. The yearly income is positively skewed. In this case, it is positive because it is going down, 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 right? It is abruptly flattening here. Okay, and most of the employees salary is between 31,000 to 70. Same thing. And only thing is the income is positively skewed. That is the difference between these two. And kurtosis, we'll discuss this later. It's already late, and few of them, they are sending the WhatsApp message saying that they need to attend office call, working night shift. Hence, what we will do is this Friday we will continue the session. Today is Wednesday. What you do is you watch my today's video sometime tomorrow. Day after tomorrow we will continue the session. Okay. Okay. This is a comp of, right? Because record this one also on the sorry. So this is where you need to click on it. If you have not yet, see, the login credentials is already shared to you, but those of you have not yet received, please WhatsApp me. I'll ask my people to create the login credentials. So first you need to log into my website with the credentials shared with you. Okay. Once you log in there, 1 second, let's open something else. Let me close this one, some confusion happened. Once you log in there, in the menu, courses menu, you will find the data science and other things. Okay, you have some pre-recorded videos also, you can watch it, and study material will also be there. And the recorded videos for this video, live session videos, will also be uploaded in my website. Henceforth, they can watch the uploaded videos from my website itself. Anyway, it is taking time. Okay, some problem happened. Let me do one thing. Any other questions? Study materials, video, pre-recorded videos, and the live session videos also, you can find it here. I'll just quickly show you this one, the deep neuron.in. And sorry for the delay for in sharing the the login credentials, because our people are busy with other work. Power data science course, a full stack data science program. If you click on it, it will take you here, and even I don't have the username which I shared with you all. And you need to see if you could have logged in there already, it will not ask you this one. Let me see if I can see change their password. Yes, once you log in here, you will find some. Click on any one of them here. You need to scroll down. Once you log in, you need to scroll down there. And if you see here, you will find the descriptive statistics part 1, the videos, and if you scroll down here, you can see the case study assignment and study material, measures of spread, study material, measures of spread, everything you can see it there. Okay, this content is empty. I will check in case of anything missing out, because just now we restored everything, and also we are planning to upload the new materials, the up-to-date one. Okay, and the download data sets, also here also we will upload all the necessary data. But at this moment, what you do is start with this one, the videos, whatever I covered, right? You can see it here. So far whatever I covered, those videos, you can see it here. So here part 1 and measures of dispersion. If you click on this, you can read it. Okay, same thing. Okay, you can see it here. Okay, and if you go back here, when you click on this logo, it will take you to the home page. Let me do it. When you click on this logo, it will take you to the home page. That is common, like in all the other website, right? So here, data science courses, you will find a lot of things here. Advanced NLP with Python, natural language processing, and for this and all, we will upload the video. Already we uploaded. Due to some crash, we lost a lot of it. I think it is available already.
Before we get started, I want to go over some assumptions about the background.
See, we have some, we got some approval from these US guys to, with their approval, we uploaded their course videos also. And anyhow, we need to do some designing. Okay, the size and all very small, right? So you can watch these videos also. Okay, all these videos, pre-recorded videos. But here, full stack data science, this is where you can find my study material. And the videos, the live session videos, you can find it here. Okay, and these are all complimentary. If you want, you can go and watch this one. So MySQL, if you are very interested, you can click on MySQL, Tableau, SSIS. All these things are complimentary. Blogs are also available, and let me see. Yeah, the blogs are available, but it is not related to data science. We will include data science also little later. Okay, already we created blogs for data science also. But we hired some guys, bloggers, to write good content. We uploaded everything, got crashed, and we are gradually restoring it. At this moment, you log in there, and then you just go to the data science course, click on the full stack data science program. Okay, that's all. You should be able to view the videos and study material, everything. Gradually, we will also check everything is available in place. If anything is missing, we will fix it then and there. Okay. Alright, since you don't have any questions, I'm going to wrap up the session. We'll upload the video as usual in the YouTube for the time being. So from this upcoming weekend onwards, you can see everything only in my website. Okay. Alright. I'm going to wrap up now. This Saturday, Sunday, we will circle back. Okay, don't forget it. So we'll continue the measures of other measures of dispersion in today's session. We discussed about the range standard deviation. So far, using standard deviation, we can compare more than one data set. Within a single data set also, we can compare like how far each value is away from the mean. So we need to understand the distribution pattern of the data. This is right based on the but we hired some guys, bloggers, to write good content. Over standard deviation. So now quartile, which is nothing but